In yesterday's lesson, there were a couple that were a little bit confusing. So I want you to take a look at this question and decide which of these students you agree with, and then you need to explain why. So make sure you're using complete sentences when you're explaining. Yes, you can. Cornelius asked a good question, and he asked if you can agree with more than one person. And I will say yes. And we're about ready to share. How many people need a little more time? So I'm just going to give you one more minute. We're about ready to share with partners. So need everybody making sure that they're at their desk. They're ready to share with a partner. Cornelius, you need to be back at your desk. It's okay. So I'm going to have you share with your partner, and I want you to share your answer. I'll tell who goes first, odd or even, who you agree with and why. And I know there were a couple people that agreed with more than one person. So when you turn to your partner, I would like the odd person to start and share yours, and then the even person can tell. So go ahead.
With Terry, because there is two shapes shaded and there is one of the thirds, so that makes 2 and 1/3. I agree with Juan because there are 3 equal parts in each pie and 7 are shaded.
2 holes shaded in and 1/3 of the circle is also shaded. I also agree with Juan because 1 hole shaded equals 3 and 3 times 2 equals 6 plus the 1/3 shaded equals 7, 9.
I agree with Terry because she wrote 2 and 1/3, and if one pie is fully colored, then it is 1 whole. I also agree with Juan because the denominator is 3 and there is 3 pieces in 1 whole. And if you count all the pieces, then it is 7. It is also an improper fraction.
I agree with Terry because I saw 2 is shaded all together, and that will equal 2. And I saw 1/3 that was shaded in, and that will equal 2 and 1/3.
Okay, if you agreed with Jasmine, can you give me a thumbs up? And if you agreed with Terry, can you give me a thumbs up? So I would like someone who agreed with Juan to raise their hand and tell me why they agreed with Juan. And now, Abigail, why did you say thirds?
Because each circle is cut up into 3 pieces.
Yeah, and so that we said that these were pies, so each pie is cut into 3 pieces. And when you're talking about the denominator, what does that 3 mean in a denominator? 3 what? 3 pieces do what?
3 pieces in a whole.
3 pieces in a whole. And can you come up and point out of 9? Where do you see the 9?
There's 1, 2, 3.
Loud.
There's 1, 2, 3, 4, 5, 6, 7, 8 pieces.
Thumbs up if you can see the 9 that she pointed out. Nara, what's similar about these 2 fractions? What do you see that's the same with these 2 fractions? What do they both have? Just by looking at the fractions, what do you see that's the same? Hands down. They both have a 7, and we counted those 7. Janelle counted those 7. So the difference is the denominator. Abigail, what did you say a denominator represented?
How many pieces in a whole was?
How many pieces are in a whole? So thinking about a whole pie and deciding if you agree with Jasmine or with Juan. So I want you to talk to your partner again. Do you think there are 3 pieces in a whole pie or 9 pieces make up a whole pie? So turn to your partner, even start.
I think June's right because there are 3 parts in a whole.
I think Terry's right because there's 2 holes and 1/3 of pie.
And you're going to put thumbs up if you think 3 pieces make up a whole pie in this diagram. Okay, and now thumbs up if you think that 9 pieces make up a whole pie. So now I need somebody with Terry. Who thought Terry was correct? Who thought Terry was correct? Cornelius?
I believe that Terry is correct because there are 2 full circles shaded in, and then so that's 2 holes, and then they only shaded in 1/3 of the other one, so that's what represents the 1/3 of the fractions.
Thumbs up if you see the two whole pies in the diagram. Here your body. Okay. Cornelius, can you explain the 1/3? What does that mean?
The 1/3 means that only one out of 3 pieces are shaded in.
Thumbs up if you see that 1 out of 3 shaded in near your body. Okay, thank you. How many people think that there might be more than one right answer? Raise your hand if you think there might be more than one right answer to this. Hands down. Who heard Abigail's word that she used to show more than one fraction representing the same diagram? Maria, what word did you hear her use?
Improper fraction.
She called this an improper fraction. What would we call this? It's not an improper. Michael?
A mixed fraction.
Mixed number. Yeah. We do have a fraction and a whole number, so it's a mixed number. And then Abigail used a word that indicated that these two representations were the same. Did anybody hear that word that Abigail used when she was explaining? Abigail, I know you heard your word. Kyle, did you hear the word?
Equivalent.
Yeah, so these two would be equivalent. Okay? So we're going to do a little bit more work with fractions today, and we're going to start out with our whiteboard.